notation. Like all good notation, exponential notation is there to save us writing. So, if we wanted to write 3 plus 3 plus 3 plus 3, add a bunch of 3's together, it gets really tiring, and especially if you have 10 or 15 3's, we don't want to write that over and over again. So we have a new operation, and that new operation is called multiplication. We know this. We can write 3 times 4. Those are equivalent because there are 4 3's, so we can write 3 times 4. Similarly, exponential notation is simply repeated multiplication. If I want to write 3 times 3 times 3 times 3, I can do it in steps, but today we're not concerned with solving what an exponent is, finding an answer, a concrete value. What we're looking for is just to denote, find a simpler way to denote 3 times 3 times 3 times 3, which is 3 to the 4th power. In general, we will have a number, in this case I'll call it x, and you will have it repeated n times, whatever n may be. And in between it, we will have multiplication. So you will have x times x, and you'll have x multiplied together n times. Okay? The x is referred to as the base, and the n is referred to as the exponent. An exponential notation is indispensable for writing things, especially in subjects like science. When we talk about how many millions of bacteria fit in a petri dish, we might have millions upon millions upon millions, and we don't want to have to write that huge number out, so we can use exponential notation. We might talk about how small something is, and we might have to talk about negative powers. We will get to that. We also want to note that sometimes we have negative numbers multiplied together over and over and over again. So if I have negative 2 to the 3rd power, it's important to mention, I always want to put parentheses around the negative number. It prevents ambiguity. It prevents me questioning, do you mean 2 to the 3rd power and then make it negative? Or do you mean negative 2 to the 3rd power? So putting that parenthesis in there helps us get it right every time. So that tells me that it's negative 2 times negative 2 times negative 2. Not that it's, if I wrote this, I could think that it's 2 times 2 times 2 made negative. So we always want to put those parentheses whenever we can, whenever we see it necessary. All right. Now, the other thing that we discussed today was whether or not an exponent will yield a positive result or a negative result. So, if I have negative 2 to the 1st power, I know that that is just negative 2 written one time. If I have negative 2 squared, or to the 2nd power, I would write negative 2 times negative 2. And we know from previous math knowledge that a negative times a negative is a positive. So we would get a positive 4, or in general, we got a negative result with this one, and a positive result with that one. Now what happens when we do negative 2 to the 3rd power, or negative 2 cubed? We would have negative 2 times negative 2 times negative 2. And the first negative 2 times negative 2 is going to yield a positive result, in this case positive 4. And when we multiply positive 4 times negative 2, we're going to end up with a negative 8. So we're yielding ourselves a negative result. So let's try it again with the fourth power. I'm going to have negative 2 to the fourth power. And if I list out negative 2 times negative 2 times negative 2 times negative 2, the first 2 will yield me a positive result. In this case, it's positive 4. If I multiply positive times a negative, positive 4 times negative 2, I'm going to get a negative 8. And then when I go ahead and turn around and multiply it by another negative 2, you're going to end up with a positive 16. So in this case, we'll end up with a positive result. And as you keep going, this pattern will continue because every time you add a copy, it's going to end up being the opposite. So it'll start out negative, positive, negative, positive. So in general, odd numbers or odd powers yield a negative result, and even powers yield a positive result when the base is a negative number. So anytime I would have a negative x to the n power. If n is odd, it's negative. If n is even, it will be positive. So we need to know how to go back and forth with the powers as well. So if we have the number 2 to the 7th power, and we know it's 2 7 times, and it's all multiplied together, and we need to be able to go backwards. We need to be able to see if we have written 3 times 3 times 3 times 3, then it's going to be 3 to the 4th power. So we need to be able to go back and forth between the exponential notation and expanding that exponential notation out. And we need to know if the answer is going to be positive or negative.